Good afternoon, everyone. Thank you all for joining us on day 2 of Carbon Crunch 2021. My name is Caroline Pye. I'm an energy sector account leader at Mott MacDonald, and I'm delighted to be your host for today's webinar. Today's focus, if we could today's focus is on the energy sector, which is of course integral to the decarbonation of all infrastructure. As an example, the energy infrastructure associated with heat and transport will become more intrinsically linked, and with increased electrification and hydrogen uptake required in both sectors for credible net zero scenarios. Delivering this to meet UK's 2050 net zero target will clearly require more systemic thinking than we've seen to date. With this transition will come a series of challenges and opportunities as organisations adapt new business models and technologies. Today, we're going to hear how 3 leading organisations are navigating some of the complexities in energy decarbonisation. Taking a brief look ahead at the rest of the week, on Wednesday, we will be focusing on transport and how we will respond to adapting technologies and travel needs. And on Thursday, we're going to be looking at the built environment, particularly heat, retrofit and embodied carbon. We are putting the registration links in the message function now for anybody who's not already registered for these events. Before we move on, just a few small housekeeping points. Following all of the presentations, I will be directing your questions to our speakers, so please do submit your questions using the Q&A function, which will be open from now. If you see a question which you do like, please do click on the like, because we will be aiming to answer the most popular questions. We will try and answer as many questions as we can in the time allotted. We are aware that yesterday there was a problem with the Q&A function. Some attendees did have issues posting questions. We think this is an issue with Microsoft Teams at the moment. So if you do experience any issues, please try and log out of the session and log back in again. And if that doesn't work, please email any questions to Mark Crouch at mottmac.com, whose email should be coming up on the message function now, if you do need it. Please also be aware that this webinar is being recorded, and we will send a link out to the participants afterwards if you wanted to catch up on it again. We'll also be issuing, publishing a report following the event, so we can capture interesting questions from the Q&A, even if we don't get to them in the call. So today's presentation then, on the next slide. Today's presentations will focus on the cross-sectoral decarbonisation opportunities within the energy sector. We have a great line of speakers, with Russell Fowler discussing National Grid's role in decarbonising transport, followed by Stefanos Agnostopoulos from Piclo, who will be discussing new markets to support grid flexibility, and finally Joe Devlin from Power NI on the role of hydrogen in energy systems. After the 3 presentations, we will have the Q&A sessions with all of our speakers, so please submit your questions throughout the presentation. So with that, I'll hand you over to Russell. Thank you, Russell.
Thank you. Hello, everyone. My name is Russell Fowler. I'm from National Grid, and I look at transport decarbonisation. I've got around 5 or so minutes, so it's obviously a very detailed subject, but I'll hope to take you through a kind of brief introduction to National Grid, why we are interested in transport as an energy network company, and focus on 2 particular areas where we can directly support the decarbonisation of transport. So if we move on to the next slide, it's always good to start with an introduction about who National Grid are. Lots of people have heard of National Grid, and lots of people know what National Grid do or think they know what National Grid do. So it's always good to kind of clarify what we are and what we aren't. So we own the electricity transmission system. So this is the high voltage electricity system. So linking the analogy to transport, it's like the motorways and A roads of the electricity system. So moving electricity from the large power stations. Historically, that would have been coal and fossil fuels, but increasingly cleaner technology such as offshore wind and nuclear to where it's needed. So National Grid don't buy and sell electricity, and we don't own power stations. We move that power from where it's created into the local network, where it then moves into your home or your office. We also have some other businesses. We also own the gas transmission system, so this is the equivalent on the gas side as well. Another part of the business also operates the system, so this is making sure the electricity is balanced on a second-by-second basis. But I'm here today to talk about the physical infrastructure part of the business, so that's the wires and the substations. There's lots of statistics on that sheet, so you can read them, but one is worth noting is the kind of reliability. So it's worth noting in the UK we have a very reliable electricity system. That's something I'm very proud of, and that's something that will be key when we look to decarbonise transport. So if we move on to the next slide, I think that's very interesting, and I kind of get the role of National Grid, but why are you interested in transport? Of course, we know we need to decarbonise the UK economy. So by 2050, we need to be net zero, so producing no carbon at all. So how do we do that? Well, like any complicated problem, you take it kind of sector by sector. And if you look at the breakdown of what's creating emissions, you can see there that transport is the largest emitting sector, ahead of the energy sector and businesses and homes and agriculture. If you looked at this chart 5 or 10 years ago, the energy sector were in the largest emitting sector. That's because of fossil fuel power stations for coal that is increasingly being shut down at the moment. So the energy sector is on a decarbonisation journey as well. National Grid's at the heart of that, so supporting the uptake of renewables and flexible and generation interconnectors on the system, so energy can move around the system more efficiently and cleaner. So it seems a natural sector for us to say, well, how can we support transport on their decarbonisation journey? If you take a kind of step down a little bit from the kind of the global issue of carbon emissions, which are incredibly important, there's more of a kind of local issue around air quality as well. So poor air quality created from exhaust emissions of combustion engines are one of the reasons for kind of poor health outcomes. So for everything from premature deaths to asthma to kind of general poor kind of life outcomes as well. That's something that we're very keen to make sure eradicate it as well. And of course, there's an opportunity for the UK to become a kind of leader in electric vehicle infrastructure there. So add those together, there's a kind of clear role for National Grid to play. So if you move on to the next slide, we can talk a little bit about kind of how we can bring National Grid's kind of core business, if you like. So the core business, a lot of people will say for National Grid, well, that's linking big power stations. So you should link power stations to the grid. And one of the biggest challenges that we're going to have in the next 10 years is 40 gigawatts of offshore wind. So at the end of last year, we had Boris Johnson launch his 10-point plan. One of them was making clean transport. The other one was making clean energy. And one of these was offshore wind, almost making, I think his phrase was the Saudi Arabia of wind. So that's a lot of offshore wind that needs to be added. There's around 10 gigawatts of offshore wind at the moment. So that's a quadruple in 9 years. So we have that. We have enabling the decarbonisation of transport, what I've talked around. There's two other points. Of course, this collaboration, National Grid can't do this on its own. We need to kind of work with the wider energy industry, with the renewable sector, with the offshore sector, and with the transport sector to get all these together. So one of our key things we always like to say here is this is collaboration across all of industries here. Of course, there's a technology agnostic place. When people think of transport decarbonisation, they initially think of batteries as well. But of course, there are hydrogen vehicles out there as well. Especially on the heavier side of it, where hydrogen will probably be the kind of likely solution, and kind of we're technology agnostic here. So whether that's energy to plug into a battery or whether that's energy to create green hydrogen, we're there to support that. So if you move on to the next slide, I'll very briefly kind of talk around how these two kind of pillars of National Grid, if you like, kind of work together. So we know on one side here, you're going to have lots of electric vehicles. We know there's a target by 2030 to ban the sale of diesel vehicles. And by 2050, lots of estimates there, but the entire fleet will become electrified, light vehicles as well. And of course, you need to make sure that you've got the power for those vehicles there. So that's the offshore wind on the other side. So National Grid connecting offshore wind, but also lots of electric vehicles on the other side. It's obvious that those electric vehicles need that clean power, but the other side is maybe something that's maybe not so obvious. So this is where smart and flexible happen. So smart charging and flexible ways to charge your vehicle. So for instance, charging your vehicle overnight or when it's windy or it's sunny kind of helps enable renewable power. So you can more optimally add renewable power to the system and help manage that system in a more efficient way. So you have flexible demand to marry with your variable generation as well. So there's a nice synergy between electric vehicles and renewable power. So that's kind of at the large level. If you take it down to a little bit more specific, if we move on to the next slide, you can see how you can have a more direct role in supporting transport decarbonisation. So this is a project, it's called Project Rapid. This is a government piece of work from a department called OZEV, so the Office of Zero Emission Vehicles. And they have a plan to make sure up and down England, because transport is a devolved matter, so this is England, Wales and Scotland will have their own projects. This will look to make sure that there are rapid chargers. So these are the kind of chargers where you can fill your, or charge your vehicle, I should say, in around 15 minutes or so. So you come into a service area, you do what you need to do there, you come back and your car is charged and off you go. So the idea that every service station, there will be a sufficient number of rapid chargers. So when we have a full uptake of electric vehicle, there's funding been allocated for this. There's £950 million, and this will go to every motorway service area. That's around a 30-mile gap there, and there's various kind of milestones that we'll put here. So you can see 2023, you're going to need 6 chargers at each one, but across the whole network by 2035. So when you're expecting everyone to be buying electric vehicles, you're going to have around 6,000 across those 110 sites. So there's a direct role here for National Grid and the network companies to make sure the power gets to these service areas. It's quite energy intensive, so you need a lot of power because these are rapid charges, and you need a lot of them because every vehicle is going to be electric in this future. So you need a substantial network connection to be able to do that, and that's where National Grid can help directly support that, and supporting the local networks to get that power directly in there. So that's 2 real high-level examples of how National Grid can help support transport. I mean, my final slide is my contact details. Happy to take questions in the Q&A, of course, but if people want to contact me afterwards, more than happy to carry on the conversation. Thank you.
Thank you, Russell. Great to see all that work that National Grid have ongoing, making that transition to lower carbon transport a reality. So moving on from that, I'd now like to welcome our next speaker, Stefanos from Piclo, who are creating a marketplace for energy flexibility. Organisations across all sectors are increasingly having to engage with flexibility in a power grid that is becoming more decentralised. So over to Stefanos to tell us a little bit more.
Thanks, Caroline, and thanks, Russell, for the previous presentation. Indeed, very interested, and I think we all need to work collectively in order to achieve our net zero targets. So, as Caroline said, Piclo is an independent marketplace for trading energy flexibility online. I will deep dive in the next slide a bit more what that means. But first, if we can go to the next slide, please. Essentially, what that means is, like any other market, we have buyers and sellers, and Piclo what has done has facilitated and streamlined a process where transmission networks, distribution networks can present to the Piclo where they have constraints on the network, and they can request from virtual power plants, aggregators, EV chargings. We have a big variety of ecosystems of assets currently on the platform to support the network. It doesn't mean that we are replacing the traditional reinforcement that the substations needs or networks. Essentially, we are trying to minimize this cost and decarbonize the local grid. If we can go to the next slide, please. So this is an overview of how things have changing. So on the left-hand side, you see the old system, which centralized and analog, where National Grid and the system operator essentially wanted to ensure that there is enough security to the system and enough balancing. But now with high renewable penetration and electric vehicles to the grid, things become a bit more complex. So on the right-hand side, you see that still National Grid ESO is still trying to balance the grid and keep the security, but we have congestions on the distribution level as well, and then we have the local balancing where Piclo comes into the picture, and of course self-consumption and energy efficiency. I think more or less everybody's become more aware of the energy usage over the time, especially now with the prices so high. I think everybody's more concerned where they should put the tumble dryer on or not. So And as you can see, the system becomes more complex, but at the same time, it's quite exciting. If we can move to the next slide, please. So this report actually is from the future energy scenarios from National Grid. We use these figures to show how energy flexibility on the distribution level can help. So as you can see, in order to reach our net zero scenarios, we have to reduce 100% our gas boilers. The heat pumps need to increase. The hybrid heat pumps also need to increase by a lot. The district heating and other kind of heatings. In the transport, which as Russell very well mentioned, is one of our biggest polluters. We need to replace petrol and diesel cars and vans by 100% to electric vehicles in order to reach this future scenario. But why DSO flexibility and why PICLO is interested in that is if we can move to the next slide, please. Here is how PICLO and how distribution system operator flexibility can actually maintain a very well balanced to the grid. As you can see on the figures there, smart EV charging, not vehicle to charge, is being dispatched dynamically, and other more decentralized technologies can save up to 2.7 billion per year. Currently, the consumption in the UK is 60 gigawatts roughly, and the dotted line that you can see over there is the increased need that we're going to have in the future, where DSO flexibility and decarbonise technologies can help balance it in order to avoid deploying carbon intense solutions as coal power station. There is a link there for a white paper. We've done a couple of white papers talking in depth about it because we believe very much in the mission of decarbonization. This is why we move. But apart from the theoretical part, if we move to the next slide, I can show you the overall benefits of participating in DSO flexibility. So PICLO Flex currently is in contracts with 4 main distribution system operators across UK and Ireland. They have been up to today almost 2,000 competitions. A competition is a localized area on the low voltage network where, as I said, there are constraints, and through those competitions they've been awarded 55 million in contracts. The competitions currently are being held in the platform, so we're expecting to reach the 80 million threshold. But to give you an overview of the market, when we started in 2019, the market was only 38 megawatts. In 2020, the market skyrocketed to 170, and as we speak today, the market has reached to 350, and we still have more competitions to go. I think this is a great additional benefit to other services that distribution energy resources can use, complementary to National Grid services, in order to help accelerate the net zero. We are reaching to my final slide. I wanted to keep it brief, where here's an overview of the ecosystem of participants. I think one of the important aspects of DSO Flex is to show to people how they can benefit and who is taking benefit from this 55 million. So you can see energy retailers, aggregators, large end customers, storage innovators, EV charging and project developers. You can see companies from Thames Water, Suez, Kiwi Power, Octopus Energy, that they're all participating on DSO Flex, and they've enjoying this revenue. Thank you very much.
Thank you, Stefanos. It's really exciting to see the decentralized network really becoming a reality. So moving on then, finally we're going to hear from Dr. Joe Devlin, who's a senior analyst at Power NI, and Joe is here to tell us about the work they're doing to develop a hydrogen economy in Northern Ireland, where the electricity grid has some of the highest degrees of renewable penetration in the world. So over to you, Joe.
Thank you very much, Caroline. And it was great to see a PowerNI logo on Stefanos' slide as well. So good afternoon. My name is Joe Devlin, Senior Analyst with PowerNI, and we are the largest energy supplier in Northern Ireland. And as part of the wider Energia Group, we're investing over €3 billion across a range of major renewable energy projects, including onshore and offshore wind farms, solar power, and hydrogen fuel generation. So if we go on to the next slide, please. So far, the fight against climate change has taken place predominantly inside the realms of power systems. Arguably, this is why it's been so successful. The homogeneous nature of electricity means businesses and consumers haven't needed to do anything differently. Whilst not overlooking the foundational shift to renewables that have occurred on both the GB and Irish power systems over the last decade, when we step back and evaluate our progress, we can confidently say that all of the easy stuff has been done. The challenges to get from 0 to 40% renewables are much different to those that we need to overcome to get to 80 to 100% renewables. And on the island of Ireland, we've been endowed with a phenomenal wind resource, both offshore and onshore. The transmission system operators EirGrid and Sony are leading the charge on instantaneous wind power penetrations, currently at 75%, with plans to get to 95% by 2030. But we all know that overcapacity is a feature and not a bug in a decarbonised energy system. And this is especially true on the island of Ireland, where installed wind power capacity is forecast to eclipse median peak demand by 2027. And the map on the right here shows the significant commitment we as a company have made to delivering this wind capacity. And it's this over wind capacity that presents a phenomenal opportunity for us to not only extend the value of electricity, but they also completely change how we think about energy systems. And this is where we believe hydrogen has a key role. Rather than think of hydrogen as a molecule or even as an energy carrier, we believe that it's a key link between a renewable power system and a wider net zero energy system. Next slide, please. Playing a key systems integrator role, we see hydrogen as two sides of the same coin, maximizing renewable resource and bringing sustainability to sectors of the economy where it's needed most. Overcapacity means that the wind will blow more than we need it to, and dispatching electrolyzers to turn this potential wasted power into hydrogen ensures every green unit of electricity is put to work. And this type of short-term flexibility is vital in achieving a high renewable power system. But hydrogen also provides an opportunity for seasonal storage when the wind maybe doesn't blow as much as we want it to, and it's this type of storage that we could be dearly doing with at the moment. And obviously the greenest form of hydrogen is the direct connection of wind turbines and solar farms to electrolyzer capacity. And it's this exploitation of overcapacity on the supply side that really drives hydrogen's ability to take decarbonisation to areas where electricity alone may not be best suited. Examples of key green hydrogen demand are maritime applications and the heavy transport sector, as well as the advantages ammonia production gives hydrogen as an energy carrier. By widening our traditional linear and siloed approach to power systems, adopting a solution such as hydrogen enables us to be much more ambitious around the opportunities for decarbonisation. And taking an energy system perspective, hydrogen can be viewed as an enabler and a route to market for very high levels of renewables, such as Ireland's 30 gigawatts of offshore wind potential. But as great as the potential for sector coupling via hydrogen is, it doesn't just magically happen. The difficulty with hydrogen in the short term is directly due to this classification as an integrator. It's the classic example of a chicken and egg problem. Go to the next slide, please. A hydrogen economy is a two-sided market where production technology is mature and well understood, but this level of progress has not been achieved on the demand side. Who's going to build electrolyzer capacity and invest in the production of green hydrogen if there's no demand? And if you're a potential green hydrogen customer, why would you change your processes and engage in significant capital investment if you're worried about not actually being able to source this fabled green hydrogen? And this is where we believe a very different type of nexus is required to achieve our net zero ambitions. Partnership, systems thinking, and funding come to the rescue. The only way that we've figured out how to solve a two-sided market problem is to tackle both supply and demand at the same time. Next slide, please. So that's exactly what we've done. We've partnered with TransLink, Interreg, OZEV, and the Department for Infrastructure on a pioneering project which will directly reduce emissions in Northern Ireland. TransLink's new hydrogen double-decker buses, built by Northern Ireland's Wrightbus, will be fuelled with renewable hydrogen produced at one of PowerNI's wind farms. And completing the supply chain for this project is the installation of the first hydrogen fuelling station on the island of Ireland. Whilst this project on a technical level is great for proving concepts, business models and kickstarting the hydrogen economy, it's much more important than all of these things. If we remove all the technical learning and the hydrogen specifics, what we have is a generalizable blueprint for how to collaborate across sectors to achieve our climate goals. Unleashing the power of partnerships to take sustainability as far as possible, given our current resources and capabilities, compounds our impact on climate change. And going on to the next slide, that's exactly what we've been doing. We've been following that power of partnership to really ramp up our involvement in transport decarbonisation and to transfer our learnings to the maritime space. We're members of the Belfast Maritime Consortium, a 13-partner syndicate of businesses, academia and local government. And this consortium, led by America's Cup spin-off Artemis Technologies, has received £33 million of funding via UK Research and Innovation Strength in Places Fund to deliver a net zero ferries project. And the latest project, led by PowerNI and including wonderful partners such as Mott MacDonald, builds on the work of the emerging Belfast Maritime Consortium as a global centre of excellence for zero-emission maritime technology. The Northern Ireland Green Seas project will leverage our experience to identify and investigate zero-emission solutions for port and vessel operations. Various scenarios have been developed to assess the optimal decarbonisation strategy for a large transport and freight port, Belfast Harbour, a small leisure port, Bangor Marina, and a remote island harbour of Rathlin Island. This feasibility study will consider practical scenarios to determine the energy requirements and net zero pathways for each location by 2050. And these include battery energy storage, green hydrogen production and bunkering, shoreside electrical grid infrastructure, and renewable energy supply. And underpinning all of this work is the development of a digital twin process, which will deliver cyber-secure systematic design and procurement. This project will integrate renewable resource, technology, and maritime heritage to place Northern Ireland at the forefront of the shipping industry once again by serving as the blueprint for the future of zero-emission maritime. And by taking this local interdisciplinary approach to a global problem, we can have a material impact on climate change. So in summary, whilst technical nexus are extremely important, they are only an enabler of the climate change mitigation that is required. It's a nexus of people and partnership that will truly deliver the change that we need. And this is the common theme across all of the projects we are currently involved in. And PowerNI and all of us in the wider Energia group are leveraging both the technical and people and partnership nexuses to ensure we deliver a low carbon society for everyone. Thank you.
Thanks, Joe. It's really powerful message at the end there on partnership, which is really important. There is some good questions coming in. If I could direct one of the more popular ones to yourself, Russell, regarding EVs and the sustainability around batteries. So are batteries sustainable in the long term, particularly thinking about rare minerals needed and the end of life and obviously the wider environmental impacts?
This is a good question, isn't it, when it comes to batteries and the sustainability of them in the short term in terms of minerals and kind of long term of what you do with a battery after it's finished. So I've taken the second point first and say, so what happens to a battery after the end of it? So there's quite an active market for second-hand batteries, and we talked a little bit about kind of flexibility there. So obviously electric car batteries give great flexibility, so there's a very kind of active second life market. So effectively take in the batteries out of these and turn them into static batteries, so creating kind of battery packs where you can provide services to grid as well. So even though the efficiency may have dropped from the battery for car use, it's still got a lot of valuable power in there. So that's a kind of active market at the moment. It's small at the moment because most EVs are relatively new, so most batteries are still in the car, so there's not a lot of batteries that have got to the end of their useful life, so it's quite small at the moment. There are various other plans. I was just reading something the other day where people will take second-hand car batteries and put them into classic cars, so cars that were designed to run on combustion engines and then turn them into electric vehicles, kind of a retrofit model there. So there's lots of opportunities for them. Like a lot of things, you need to make sure that the regulation and policies are in place so that batteries are disposed of safely and metals are extracted from them in a safe way, as you would dispose of anything like you think of fridges and current vehicles as well. So it's making sure that regulation is in place. The long-term sustainability is an interesting one, slightly outside of my kind of area of expertise, but you're absolutely right. We need to make sure that mining minerals is sustainable everywhere in the world, and this links a little bit into what you'll see coming up in the next month or so with COP around trying to get global standards and global agreements on things around environmental standards and decarbonisation. That it's obviously a big challenge. It's not something to be to be dismissed there, but also think about the kind of battery technology as well. So people are always trying to get their batteries kind of more sustainable and less dependent on types of metals. So there's lots of development going on at the moment, but it's definitely something that it needs to be an active area of consideration.
Thank you. So got another question here that's quite popular, which I'm wondering, Stefanos, if you would mind, in terms of cyber security around this. We've got increasing digitalisation of the power grid. How are the risks of cyber attack being managed? Now, I know you're obviously not a grid owner, but perhaps you could give your views on that one.
Hi, sorry, I'm having a hard time unmuting. Yeah, I'm not a cybersecurity expert, to be honest with you, but it's indeed a discussion that comes very often up. I think system operators are very aware of this, especially with a lot of GDPR issues in place. I think the recent leak of further documents, and I know it's not from the energy sector, I think has brought a lot of awareness. It's a very big discussion on national grid level. Russell, I'm pretty sure he knows that on the DSO and the DSOs, and they're building a large team. However, what measures specifically they are taking, I'm not 100% aware to answer that question.
So thanks, Stefanos. I think if we move on to one that's come through for hydrogen for yourself, Joe. Hydrogen electrolyzers utilising excess capacity would mean that the utilisation of the electrolyzers would be lower than 100% load factor. This means lower efficiency in operation and a lower return on investment in the CapEx. How can this be mitigated?
Yeah, that's a great question. So there are three main drivers of your levelized cost of hydrogen. So first is the CapEx cost of the actual electrolyzer itself. The second is the price of the electricity you can get to run through that electrolyzer. So in times of constraints or curtailment, that would be tending towards zero. And that has a massive impact on your levelized cost of hydrogen. And then, yes, the utilization of that asset is a material impact as well. So what we're trying to do at the moment is that we're trying to really exploit that nexus between power and energy to try and prove a use case in the early stages of the hydrogen economy, to try and get that capital investment into the hydrogen economy itself, prove the use case, and then expand from that point. That we may not be just purely using electrolyzers to increase the penetration of renewables overnight when it's really windy anymore after that. So it's basically, we're trying to learn as much as we can now, understand the actual technical systems, and try and provide some value in the short term, which we can then build on in the future. But yes, the utilization of electrolyzers is a big deal, and something that we will be working with in future to try and minimize through various different revenue streams. Maybe it's more flexibility in the power system, or it's cheaper electricity to offset that.
Thanks, Joe. Back to you, Russell. Another popular question, is the National Grid looking at delivery of alternatives to fuel stations such as hydrogen?
Good question as well. I talked a little bit about this and probably didn't go to enough detail there. So if you think the current market, it's all liquid fuels, it's diesel and petrol, and we need to move away from that by 2030, 2035. And your alternatives are battery electric or hydrogen at the moment. So National Grid's role is not necessarily to kind of set up the fueling station stuff, but making sure that underlying infrastructure is ready to support them. I suppose you could say it's for the market to decide whether you're going battery or electric, or whether you're going hydrogen. In cars, you can see a lot of battery cars there. I was interested in to see Looking at the bus example there as well, so heavier vehicles, buses, you can definitely see hydrogen going there. Great to see hydrogen buses in Northern Ireland. There's already runs around Aberdeen as well there, so you can kind of see hydrogen going into heavier vehicles there as well. So it's about making sure that the kind of underlying infrastructure can support that. So if we need to electrify kind of what are fuel stations, if you make, and turn them into electric charging hubs, we need to make sure the infrastructure is ready for that. If we need to create green hydrogen, we need to make sure the infrastructure is ready for that. The renewables are there, connecting the electrolyzers, and then thinking about how do we get that hydrogen from the electrolyzer to where it needs to go. Is it local production? Is it going to be tankered, or are you going to create a kind of a piping infrastructure to get that? So almost like a hydrogen economy, and then you can have discussions about can you use that hydrogen for heat, etc. So it's about, from our point of view, is making sure that infrastructure is there as ready. What people kind of want on the end of it, that's almost a kind of market decision to design which way the vehicles are going to go. That's a bit of a non-answer, but it's making sure that the underlying infrastructure is ready and what goes on top of it.
Thanks, Russell. We've got another popular one here. Organisations of all kinds are setting net zero targets and route maps, some with large asset bases and energy demands. For example, water companies, tech companies with large servers. Some are just office-based organisations. How can these companies unpick and engage with what is going on in the energy sector to support their own goals? I wonder if Stefanos, you wanted to answer this in terms of obviously the markets that are opening up.
Yes. Can you hear me?
Yes, we can hear you. Yeah. Oh, no, sorry, you're on mute again, Stefanos. Right. You should be off mute now.
Can you hear me?
Yes, yeah.
Yeah, fantastic. Sorry about that. So companies like water companies, I know, like after a certain amount of employees, you have the ESOS report that you have to present the kind of decarbonization targets and what organizations are doing. So organizations that they own and operate larger assets from furnaces, like Bridgesteel, for example, is a very good example of an organization participating in balancing programs. And water companies as well with the pumps. What they can do is they could either reach out to us, where we could help them understand better, reach out to Mott MacDonald. There are also groups like the Energy Networks Association that they provide kind of information. However, a good practice in general is to understand what kind of patterns they have. What is the meters? Do they need to use so much energy? They need to really understand the technology, if it's needed all the time. Can they reduce their peaks?
Thanks, Stefanos. There's a couple of questions on here about Project Rapid, Russell, if I could direct to you. Is it being deployed in coordination with local authorities, and does it include the installation of distributed energy resources in parallel to the charge points?
Good question. So again, I'll take the second question first and come back to the first one. So is it looking at the distributed resources? So yes, essentially it is looking for that. So the fund is to look to deliver the supporting infrastructure. So don't think of the actual charge points, the wires and the chargers. Think of the cables that need to go under the ground to get the power there. As I said, if you're looking at rapid chargers, these things are quite substantial. So at the moment you see things around 150 kilowatts, you could see up to 350 kilowatts, and you will need a large number of these at your service station, so 10, 20, 30 as well. So that's a reasonably significant amount of power. So think about it as the power requirements of a small town effectively going into a car park as well. So it gives you the kind of idea of the infrastructure that's required there. So that is the kind of the cost element of it, getting that underlying infrastructure in there. So it's just to support the distribution and to support the transmission to get the power into there. The general feeling, of course, a lot of the details are still being worked out of these things, is that the charge point themselves is a relatively liquid market, and you'll be able to relatively easily get charge point operators to install rapid chargers once the underlying infrastructure is there. On the first part of the question, I'd be work with local authorities. I think that's still being kind of developed. So exactly how the fund will be deployed is being kind of worked up at the moment. So the money was allocated at the spending review last year, so almost a year ago now. And OZEV, the Office of Zero Emission Vehicles, is currently working with kind of various stakeholders about how it will deploy that money. So there certainly should be some engagement with the local authorities and kind of local transport boards to make sure that that gets deployed, and with the service area owners as well to get that in there as well. But it's still being developed at the moment, so there should hopefully be some progress over the next couple of months on that one.
Thank you, Russell. I've got one here, if I could direct it to you, Joe. What are the wider infrastructure requirements for a hydrogen economy in terms of transportation and storage infrastructure? For the hydrogen bus example that was shared, was there a need to update any supporting infrastructure for the transition to hydrogen, and how was the fuel transported and distributed?
Well, that's a to be decided question, I think. Well, I look forward to getting some input from Russell on this after I have a crack at it. But yes, supporting infrastructure is absolutely vital to delivering a liquid hydrogen economy. So the way we've tackled that with our bus project is part of the funding was to get some trailers that are purpose built for transporting the hydrogen. And also we have the first refueling station on the island of Ireland as well installed at the refueling depot for the buses. So that completes the supply chain there. And we can do that because it's we're the first to do it, I suppose, and it's early stages of that type of infrastructure. But when we talk about fulfilling larger hydrogen demands on the way to 2030 and 2050, then it becomes a bigger need for a lot more supporting infrastructure, and that whether that's blending on the gas grid, or whether that's salt cavern storage, or the creation of industrial demand hubs where the production of green hydrogen is occurring in the same place that it's being used. These all depend on the size of the hydrogen economy, our ability to deliver it, and the best use cases that we can find to support that demand at the end of the day. So it's very use case specific, and there's a lot of work going on to answer those type of questions right now. And it's something that we haven't got a firm hold on yet. We're just doing what we can to make these projects and kick them off. And we'll work out those bigger infrastructure problems later down the line when people like Russell can tell me what the right answer is.
Russell, did you want to chip in with anything there?
Yes, I mean that was a really brilliant answer, Joe. I think you're right. There are lots of different options there that you look at. I mean, to pick out those ones. I think our view in the short term, you're going to see that kind of local supply and demand being really kind of well matched up as well. So then you're on to the question of in the long term, and this is probably a question for wider kind of energy decarbonisation, is are you going down the hydrogen economy route, and that will necessitate more than just transport. You're going to need to be looking at heat there as well, because we could have a whole separate conversation on how do we make heat clean as well. Do we go down the hydrogen route, so replace our natural gas we have in our homes with hydrogen, or do we go down the electric heating, the heat pump route there as well, which will kind of dictate almost a little bit about the infrastructure that you've got there. So you can certainly see a future where both of those worlds that Joe described, where you have that kind of electrification, you have that kind of local production. You can also see a world where you have a kind of more decentralized, larger scale production. You talked about kind of industrial hubs as well, absolutely getting the power into them, and then having a piped network there as well. So I think we're still a few steps away from kind of knowing which of those kind of journeys that we're going down there, but people both on the electricity side and on the gas side are thinking about those and looking up at innovation projects and development projects to work out how we can get hydrogen in the gas network, how we can blend it, and then how we can move it to 100%. And people on the electricity side are looking about how you can support hubs and how you can support the integrate the wind and the hydrogen as well. So people are thinking about it from both sides as well, but I think we probably need a little bit more before we decide exactly which route we're going to go down.
Thanks, Russell. So work in progress then is we'll leave that one. We've got one for yourself, Stefanos. What are the technical requirements to participate on the PickFlow Flex platform? And do you offer turn up and turn down services to DNOs?
Yeah, that's a very good question. Can you hear me? Yeah, fantastic. So the technical specifications, first of all, that the whole process is technology agnostic, so they are not in need for a specific technology to participate. So from an EV charger to any asset that is connected to the low voltage substation. The second thing that they need to know is that they need to be within the location, which is something they can check out on PickFlow Flex or to the representative DNO websites. The power requirements are usually very small, so you don't need to have an asset of megawatt attitudes, but like you can have a 10 kilowatt asset, a 15 kilowatt asset that can participate. And the next step that you need to do is to be a qualified supplier to the distribution system operator, which is very much a streamlined process of them understanding what kind of business you are and how you can support them in a long-term run, because usually the contracts on DSO Flex are up to 7 years. Another aspect of DSO flexibility that's quite interesting is that it's very supportive about new technologies that currently don't exist, but they are being planned or they are in development, meaning that assets that you're an organization and you want to install, for example, EV chargers, and you're doing the economics of it and you're not still very convinced of it. So you can very much easily check if you are within a constraint zone, participate to the whole tender process, secure a contract and say, okay, now I have my contract secure, I have my a part of my finance also secured. Let's start building these assets. So the requirements are very minimum, essentially, because they want to incentivize everyone to go to low carbon technologies.
Thank you, Stefanos. It's another question which I think is somewhat similar to the hydrogen bus example, but slightly more focused on safety. How would you ensure the safety of hydrogen distribution for domestic heating, and how might consumer behaviour change in terms of the cost incurred and safety? Is that something that you could respond to, Joe?
Yeah, so we are very early on the route to achieving those type of applications for hydrogen at scale, and there's a lot of great work that's currently going on to answer questions such as that. I know in University of Ulster here in Belfast that they're doing world-leading work on hydrogen safety, and there are quite a lot of pilot projects that are happening both in GB through National Grid and in the Republic of Ireland with Gas Networks Ireland, where a lot of these pilot projects are being developed, and the answers to those safety questions are the problems and the solutions are being investigated. So that's very much a work in progress, and we will continue to evaluate the progress that is being made over the next few years.
Thanks, Joe. If I could direct this one to you, Russell, would the more flexible, decentralised market mean that we need more or less grid infrastructure?
That's a good question. I suppose I'm going to say depends a little bit there. So when we see, say, decentralised, we often think of kind of smaller scale power generation. We think of solar and we think of wind and we think of batteries there. Now, of course, they all need to be linked to the grid as well. So a lot of people say, well, I want to be off-grid and self-sufficient as well. That's very challenging. It is better to be part of that grid because that's a bi-directional grid as well. So at times of excess, we see with excess wind and hydrogen, then you can get that back to the grid there, and you can enable all sorts of innovation, peer-to-peer trading as well. So you need that physical network to get in there. So it may be seen that you see a rebalancing of your network, so more on your local networks and maybe less on the upstream network. But of course, you also got very large scale economies of scale renewables. So offshore wind will need the infrastructure offshore, and then to link that into the existing system, you see large nuclear for as well. So significant infrastructure projects being built at the moment. And of course, if you take it up a level as well, you're seeing more interconnection with continental Europe. Recently, we saw the commissioning of the interconnector to Norway, the longest subsea cable in the world. So linking kind of the UK's wind resource into Norway's hydrogen resource as well. So you can see the synergies between there as well. So I'm not sure you'll see less grid. I think you'll just see it in different positions than you did historically.
Thank you, Russell. I've got a good question here for all of you. If I could ask Stefanos to respond to this first, if that's okay. So what do you expect and or hope will happen as a result of COP26, and how may this change your organisation?
That's a very interesting question that we've been discussing internally as well. I think now the need for rapid change towards a net zero is more visible than ever. I think the climate change is very much visible. What I'm really hoping for it is governments to enable distribution operators, either they're on a transmission level or the distribution level, to have the autonomy to build the smart and flexible infrastructure that's needed, and which will allow us as a marketplace to help streamline distribution energy resource assets like small domestic batteries to up to big fleets of renewables, to connect and trade with each other in order to reduce the carbon emission. I think to summarize my answer, I think is enablement to the organizations that they need to act, rather than having long-winded conversation about what is needed to happen.
Thanks, Stefanos. Let's keep our fingers crossed. If I could ask the same question to Joe.
Yeah, quite similar. I think we need there's a need for an element of certainty and a bias to action, because the ability to deliver on net zero, it starts now, right? It takes years for it to become an overnight success. And they're very real deadlines for us to meet here, and good intentions aren't good enough if we drift past 1.5 degrees. So the time for action is now. No more delaying tactics, no more distractions. And there's a job to be done, and hopefully our world leaders can commit to that and develop a bias for action during COP26. So ultimately what I'd like to see at the end of this is better supporting policy and legislation, more resourcing in critical government and state agencies, and enabling markets for supporting technologies for the integration of higher levels of renewables, such as flexibility markets or hydrogen economies.
And Russell, from yourself.
That's great. I'm not sure I can follow those too much, so I agree absolutely with what's in there. I suppose looking from kind of the energy system and look at transport as I do, having that kind of holistic look across everything as well. So we often see kind of targets in silos. So I'm going to decarbonise energy or decarbonise transport, decarbonise heat. It would be nice to take that upper level and say, is there a broader net zero or a decarbonisation framework that we can go to, rather than risking siloing things or people waiting for certain things to happen there. So the argument you often see is, well, I'm not having an electric car because the electricity system isn't clean or the production of the vehicle isn't clean. If you have a holistic view, you can kind of get around those issues as well. And of course, they've got to be done internationally as well, because a lot of the arguments we often see against decarbonisation is, well, there's no point in me getting an EV because something is happening in another country as well. So having those global agreements, global standards as well, really help kind of move us towards decarbonisation, because, you know, in all parts of the supply chain, are being cleaned in all parts of the supply chain across the whole world are being done. So looking holistically and getting that global agreement is kind of key to me. And again, I hope our world leaders can step up when they need to be able to deliver that.
Thank you, Russell. Got a good question here. It might be interesting to hear your views, Joe, in relation to the skills gap that needs to be addressed to deliver more sustainable energy. Do you think there is a skills gap there?
Absolutely, I think there is, definitely. Even just looking at energy efficiency, whether it's around insulation or the installation of heat pumps, or even just the technical skills from a hydrogen perspective. These are all, maybe they're not new fields, but maybe they're fields that haven't been really to the fore previously, and haven't maybe been seen the focus and the funding that they that they need to get to make a material impact on our ability to achieve our climate ambitions. So absolutely, I think jobs and skills are a central pillar to the energy transition, and it also correlates well to delivering an equitable transition as well. So maybe there's some jobs that can be retrained to deliver the net zero rather than brand new jobs that result in a net decrease. So there's a huge parallel between green growth and green jobs growth, and the right skills and training are absolutely fundamental to achieving those targets.
Thank you, Joe. And probably have time for just one more. Do current market mechanisms hamper the deployment of sustainable energy in the UK? Stefanos, is that something you can take? Is Stefanos still with us? Yeah, no, I think we've lost Stefanos. Sorry, but great work, everybody. Thank you. I think we're running out of time, so if I could just ask you to look out for the post-event write-up, which would be released in the near future, and this will summarise the key themes that we've discussed over the course of this week. Also, please do look out for our new climate change web pages. The links should be being posted in the chat as I speak. The themes that we're currently looking at this week do link in with our other Mott MacDonald COP26 activities. These do include the Resilience Hub, the Sustainable Innovation Forum, and a range of other virtual and in-person activities from our Glasgow office. We hope that you can join us at some of these activities throughout the COP26 period. Before closing, if we could have a look at tomorrow's agenda. Tomorrow's webinar will be at the same time. We will be exploring how transport is responding to rapidly changing technologies, behaviours and energy needs. Tomorrow's presenters include Leon Daniels, OBE, who's the Vice President of the Chartered Institute of Logistics and Transport, and also a member of the Department for Transport Net Zero Transport Board. We also have Angie Kloot, the Lead Carbon Specialist at the Rail Safety and Standards Board, and Myri Joyce from Mott MacDonald. So looking forward to seeing that to that tomorrow, and hope you can all join us again. And before we finish up, I'd just like to thank all of our speakers today, and thank you for attending and contributing to the Q&A. Thank you. Goodbye.